Hi there YouTubers, welcome back to my channel, Workshop Fun. Today I'd like to talk about my rectifier. I've just completed doing it up not long ago and making a stand. I'm just bringing it down so you guys can see it a bit more. And I'd also like to discuss some things I've found out about welders and how they work and the different currents that we have available to us with stick welding. So this here is my Westinghouse, well hang on, no, it's my EMF rectifier. It's a 350 amp. It's got a smoothing coil in it and it's got your Westinghouse silicon diodes. So as you can see, she's a big old beast. When I got it, it certainly wasn't in this order. I've done quite a lot of work to it. I've repainted it. I've milled out a plus and minus sign. I've turned around and made up some brass thumb screws, as you can see, 1, 2, 3, 4 for the plate. That's the old information plate. I thoroughly cleaned the inside out with an electrical spray and turned around and made sure that there was no more dust left in there, nothing to interfere with the rectifier. Then I turned around and repainted it with 3 coats of green. That's a hammerite green, so very good quality paint. And believe it or not, I just rolled it on, and you get that finish out of rolling it on. It's pretty cool. Levels out really nicely, this paint. The other thing I did, when it comes to this rectifier, it has really big terminals. So I'll see if you guys can't see this. I custom made these big terminal clamps for my welding leads. There you go. So I custom made those. They work really good. It's made out of 2mm thick plate copper, and soldered onto these leads as well as crimped on. I made a fold in the copper and crimped it on really tight with my big vise, and they certainly won't be going anywhere, and you get good contact on the rectifier. Okay, I'll just put that back on. There we go. There. So this rectifier, it says on here, maximum input voltage 140 volts. So on the arc welder, the maximum output voltage it has is 90 on the lowest amperage setting. Its maximum output amps is 350 amps, and it can't handle anything more than 350 amps going into it as well. So 350 amps is pretty much your limit, but I'm only dealing with single phase, and this here is a single phase oil cooled welder, and the most it can put out is 220, so it's not going to be coming anywhere near what that rectifier can handle. And that's single phase, so home use welders, you're pretty much your max limit for stick welding is 220 amps. You can't really get past that with stick welding. So basically, if I don't really want to use AC again and I just want to use my rectifier, I can go the full range through my welder and the rectifier will handle it. So it's brilliant. It's nice to have that ability because DC welding is definitely a lot better than straight AC welding. Now, I wanted to talk about what I've found out when it comes to DC welding. Now, if you look here, here's your AC sine wave, and just getting back a bit actually, I had to look on Google and look around about how rectifiers work and figure out how come there is a voltage increase when you hook a rectifier up, so therefore an amperage decrease. So I'm just going to try and explain this on this video as best as I can, and if anybody wants to correct me, please feel free to in the comments below. But from what I can tell, a rectifier does this. Here is your AC sine wave. That's coming from your arc welder. That's without the rectifier. That's straight outright arc welding, or that is just current. That passes through everything, your lights, whatever you use around your home. Most things are typically AC. Some smaller appliances have a very little rectifier in them and convert it to DC. But your fridge, your oven, your jug, they're all AC. And that's what goes through them, and that's what also goes through an straight outright arc welder. So how do you convert that to DC? Well, you do that by using diodes. And the diodes turn around and basically make the current a rough DC. And they do that by basically turning around and making it so the current can only go one way. It can't alternate. Now how the diodes do that is they're basically like, well, they are the electrical non-return valve. So they turn around and make it so the current can only go one way, but it can't go back. It has to stay going one way. And that's how you get your rough DC. So this is without smoothing coil. We'll get to that soon. So instead of having a negative and a positive, and then so you got negative, positive, negative, positive. Now you got two ripples up here, up the top, and they are just positive. So there's the two of them, and they go right up the top of the sine wave. Now, as you notice, I drew this quite rough. Now we'll get to the next bit of paper here. Now see how I've drawn the ripples finer than the last bit of paper. That is because with a good rectifier, you'll have a transformer or a capacitor, and what that does is it's a smoothing coil, as I've wrote down here, and that once your current has been converted to DC in your rectifier through the diodes, it is then shot through a smoothing coil, and that smooths out the ripples even further, so you get a closer, more genuine DC current. It's still not perfect, it's not as good as what you'd get in a battery, but it's pretty darn good, and it's a heck of a lot better than the AC, as you can see. Now here in New Zealand we work at 50 Hertz, so this, or these, are happening at 50 times per second. It's pretty incredible when you think about it. Now the next thing I also noticed is when I checked my current coming out of my arc welder and then checked my current coming out of the rectifier, I noticed that there was quite a big current increase. Not current, sorry, forgive that, that's actually incorrect. Voltage I'm talking about. So I checked the voltage on my arc welder, and then I checked it on my rectifier, and I noticed that there was quite a sizable voltage increase out of the rectifier. Now you can already see why if you know what you're looking at in electrical terms here. AC going up and down like this. DC, once it's gone through the rectifier and the smoothing coil, it is closer to the peak voltage that you can have. It's like here in New Zealand things are rated at 220 volts, but you know, it can, you sort of, that's an average. Sometimes you can, you know, have 240 volts labelled on things, and sometimes you see 220 volts. It's just the average of the alternating current. DC is pushing it closer to the peak once it's gone through the rectifier, because it's smooths that current out, so therefore it can go higher in the peak range of the current. So that was interesting. I had never come across that until just recently, and yeah, that was quite a new one on me. I learnt quite a lot. So I had to go through Google and learn about the different rules of current and all of that. I knew some of them from my electrical engineering studies, but I'd never done too much to do with rectifiers in my studies. I should have known a little bit because I had done some on diodes. Now, the next thing I want to cover is Dcep, so DC electropositive, DC electronegative, and AC, where AC fits in. Now, this is the order actually, how it works really, from what I've found on Google. Dcep, so DC electropositive or reverse polarity, is the best. AC is sort of the happy medium between these two, and DCEN, so DC electronegative or straight polarity, is the worst. Well, not the worst, but penetrates the least. So, when you're wanting to get good penetration with your weld, DCEP or DC electropositive, reverse polarity, best one to go for. AC, if that's all you got, then AC is a really good happy medium. DCEN, if you're wanting to weld sheet steel, it's brilliant. Like, you know, if you're wanting to weld fine steel and all you got on hand is a stick welder like me, that is the best way to go, DCEN. So that's basically what I've learnt through looking at Google and going through a lot. I read through quite a lot of forums, and I just tried to get the basics out of all of those things. Didn't really need to take away all the technical stuff. I just wanted to get the basics down so I could sort of figure out good ways of welding. So now what I want to do is I want to give you guys a demonstration of DCEP and DCEN. So I'm going to try and cover that today with a little demonstration. So I've got my welder all plugged in and ready to go, and we'll give that a go. So I'm just going to bring the camera over. I've got a bit of sheet steel set up in my vise here. I'm just going to raise this up as much as I can, the camera. Here we go. And we'll bring that over. Now I'm just going to get my welding helmet, and I'm going to get another glove on just to protect my hands a bit. Alright. So I'm just going to come around, and right now we're on DCEP, so DC electropositive. I'm just going to run a bead for you guys. Sorry, new stick, so it's taking a bit. Okay. So this is DCEP. I'm going to take my hammer, chipper, and I'm going to chip these welds. Okay. So that there is Dcep, DC electropositive. You can tell there, I've got it on a fairly second to lowest amperage on my welder. And you can see there, I've got quite good penetration. It's definitely gone in through the steel, which is good. Now, what I'm going to do is I'm going to turn around and set the welder up for Dcen, DC electronegative. Okay, so we're all set up for Dcen. Now I'll give it a go. This is actually the first time on this rectifier that I have used Dcen, so it will be interesting to see. Right, actually there is quite a bit of difference there. You can already see the difference here. Doesn't take an expert. If you look at the DC electropositive, it's really sunk in nicely, the weld. Now if you look at the DC electronegative, it's sitting right on the top of the weld. There's a huge difference there actually. And if you look around the back here, oh yep, that's quite different. And there goes DC electronegative, the back. There's the heat spot from it. Now there's the Dcep, DC electropositive. See how much greater the heat spot is. The change in colour in the steel. There's definitely way more penetration in the Dcep. So there you go. That's the first time I ever used DC electronegative on this rectifier. So I hope that helps people with welding, and I hope you guys have learnt something from that today. If you like this video, please hit the like, and if you wish to, please subscribe. Thank you very much. Bye.